Note 6.5, Part 2, Graphing Systems of Inequalities. Our objective today is to graph the solution to a system of inequalities. Just like when we found a solution to a system of equalities or lines, it was the intersection of those two lines, which was 1 point. For inequalities, it will be the intersection of their half planes. For a system of linear inequalities, the solution to the system is the intersection of the solutions for each inequality, where the regions or the half planes intersect. So make sure that you have a red and a blue pencil for this lesson so we can see the two different inequalities and the intersection of their half planes more easily. So basically we're going to graph the two inequalities on one graph. So starting with the top inequality in slope-intercept form, we're going to graph the boundary line y is less than or equal to negative x plus 2. This is going to be a solid line because it has the equals to. We'll begin the graph at 2, and its slope is negative 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Make sure you use a straight edge to draw your line. Using the test point 0, 0, since it's not part of the boundary line, we're going to determine which side of this line we have to shade red. So 0 is less than or equal to 0 plus 2. So the inequality 0 is less than or equal to 2 is true, which means that for the red line, 0, 0 is true. Remember that we always shade the truth. Our second line, so we can see the difference, we're going to graph in blue. Our boundary line is going to be dashed because it does not have an equals to. So y is greater than negative 3x plus 4. This boundary line begins at y, the y-intercept of 4. 1, 2, 3, 4. A slope of negative 3 means that you have down 3 to the right 1, down 3 to the right 1. Or if you're feeling fancy, up 3 to the left 1. Remember, this is a dashed line. A dashed line means that it is not part of the solution. Any point on this line would make the blue inequality false. Using the test point 0, 0, we are simply going to substitute in to see if it makes it true or false for the blue line. So 0 is greater than 0 plus 4. So is 0 greater than 4? No, that is false. For the blue line, 0, 0 would be false, so we shade the truth. We're going to shade the other side of the boundary line. Now notice where there are two shades. It's almost purple, or if it were markers, it would be red and blue equals purple. Now this double shaded area is the solution to the system of these inequalities, because any coordinate point within this double shaded region would make both the red inequality true as well as the blue inequality true. So the solution set, while it is infinite, is all of these points that are in the double shaded region. For example, the point 1, 2, 3, 4, 5 and 1, 2, 3, negative 4 would make both of these inequalities true. So 5, negative 4 would be in the solution set. Moving on to example 2. The red line here for the boundary line is going to be y is greater than or equal to x minus 2. So this will be a solid line beginning at negative 2 on the y-axis. It has a slope of sneaky 1, which means up 1 to the right 1, up 1 to the right 1. Remember, this will be a solid line. The point 0, 0 can be used because it's not on the line. So let's test it out. That would mean 0 is greater than or equal to negative 2. 0 is greater than or equal to negative 2, so that is true. 0, 0 is true. Shade the truth. The second inequality, which we're going to shade blue, is going to start, or our boundary line is going to begin at 2 on the y-axis. It has a slope of negative sneaky 1. So that means down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. This is a dashed line. The point 0, 0 makes this inequality 0 greater than 2 false. So for the blue line, 0, 0 is false, so you will have to shade the side of the truth. The intersection of the two half planes here is in quadrant 1 and quadrant 2. A point that we could use as a solution to this system of linear inequalities would be 2, 2. Notice that it falls squarely within both the red and the blue half planes. Example 3. The red boundary line begins at negative 3 and has a slope of 1, which means up 1 to the right 1, up 1 to the right 1. Solid line. The point 0, 0 would be read as 0 is less than or equal to negative 3. 0 is not less than or equal to negative 3. That is false. That means that 0, 0 is false for the red line, so we shade the truth. The blue inequality boundary line begins at 1 on the y-axis because that's the y-intercept. And we're going to have a slope of negative 2, down 2 to the right 1, or up 2 to the left 1, if you're feeling fancy. This is a dashed line. When there's not an equals to with the inequality, the line is dashed, meaning it is not part of the solution. A solid line means that any coordinate point on that line would make the shaded side true. It's part of the solution. So let's test 0, 0. Real close, 0, 0 is not on the line, so we can use it. So 0 is less than 0 plus 1, so 0 is less than 1. That is true. So for the blue line, 0, 0 is true, and we always, always, always shade the truth. Please continue to the class practice on the back of these notes before checking in with your teachers.